Okay, this video is to show how your eyes are absolutely fantastic and you can actually see what the real world visual wise actually looks like. This video is called Time Lapse Eyes. Now, the same way that a camera, if you point it at the night sky and take a picture, it won't give you a picture, but if you do a time-lapse photograph and leave the shutter open for however many seconds, I don't know how long they do it for, you will be able to see the stars because it lets in more light. Now, you have been told that if you stare at something and it kind of whites out, this is something to do with your brain, and the explanation is you're whiting out all the receptors in your eyes, so basically you can't actually see properly. That's the general explanation of why if you stare at something, weird things start happening. I'm going to say that's ridiculous, and your brain doesn't make things up. Your brain can see the light waves interacting on your eyes. So I've just put up a picture here of a garden. It's not my garden, it's just any garden. Now the technique is this. You would stare at a spot in the middle of that garden. Maybe the middle sunflower, who cares? I'd go for halfway down. Now the thing about your eyes is they're designed to move constantly, because if your eyes actually stop moving and stare at something, you will actually see what's going on in the world. And because everything is vibrating, so is the image. Everything is coming to you in waves. Now your brain has a switch and it ignores these wave lines. There are actual wave lines, convergence lines, like diamonds that you can see. Now I never mentioned this before because when I actually saw this, if you stare, I don't know if it will work with this picture, but it normally works outside. If you stare at the middle of your garden and do not move your eyes, I normally put a tennis ball down or something, and then, because your eyes will try and wander away, your brain will try and make your eyes move away, so you have to keep them fixed. After about a minute, everything will brighten. You are allowed to blink, but don't look away because the image will start to change. So you have to keep your eyes focused on one spot. So I never mentioned it before because I thought it might actually be the shape of our eyes. On the back of our eyes, I thought that this diamond weird pattern may have something to do with the arrangement of the photon receptors that are on the back of our eyes. So I never bothered mentioning it because I didn't have anything else to kind of show that made it anything else. So in the end I just thought, oh, it's the shape of the back of your eye. Well, no, because I've just watched a video which I've placed at the end here that shows the wave motion of waves when waves interact, and it is pretty much exactly the same as what I'm about to put on screen, because what I'm about to put on screen is the lines you will see when you stare at something for over a minute. You will see these configuration lines appear in your eyes. And why? Because these are the convergence lines of all the waves. And once you move your eyes, they will disappear, and what you're looking at will actually change completely from what it just looked like. But all these diamond lines are convergence lines, and your brain has a switch to ignore them. So what we are seeing isn't really what we're seeing. Everything is shaking, everything is moving, and it's because of crossing waves, which you'll see at the end. And just as a point that came to me as we did this, because we see everything with the waves, which are like diamond shapes and octagonal shapes and all these other shapes that you will see if you try this, I suddenly thought, why do flies have compound eyes? Well, if everything is hitting you in waves and you don't want to put as much production into that fly's brain, you take out the switch that changes these lines and gets rid of them, and you just give them compound eyes. So what they see is the original image, but because they have compound eyes, each one is separate, so that in their brain it constructs this picture on screen. And that way you have less production into the creation of a fly's brain. You can actually leave out quite a lot because their compound eyes are now taking in each octagonal diamond wave. So this is what it would look like when you try this. This is the kind of configuration you will see on your eyes. So when you stare in your garden, This is the thing that will happen to your vision. You will see these kind of lines. There'll probably be a lot more. And once you move your eyes, you'll see it all change. So, but this is the configuration. And now here's the movie showing that crossover waves show this kind of configuration. So yeah, your eyes are actually seeing convergence lines of waves, but your brain turns them off. Thank you very much. My name is Lee, and I'm a Christian.
In this film, we're concerned with the interference patterns of ripples made on the surface of water. The ripples are produced in a ripple tank by two dippers which vibrate on the surface. Light passing through the water is reflected from a mirror through a lens to form an image of ripples on a screen. We've obtained this true image by the Schlieren technique of inserting a stop in the light path. The two small dippers vibrate on the surface of the water. Each dipper produces its own pattern of ripples, and the two sets of patterns overlap. In step, they produce a pattern like this. Out of step, they're vibrating in antiphase and produce a different pattern like this. So that we can study these patterns more closely, the images formed by the ripples have been slowed to 1/24th of their actual speed by stroboscopic means. Two sources are here vibrating in phase, producing crests and troughs in step with one another. The result is an interference pattern. Along these lines, the waves from the two sources always arrive out of step and neutralize each other, producing interference fringes of minimum wave motion. Minimum wave motion, maximum wave motion. Now the two sources are vibrating in phase about 5 wavelengths apart. When the dippers are moved closer together, the interference fringes spread out. When one of the dippers is moved, these effects are clearly demonstrated. As the sources come closer together, the fringes are widely separated. When the sources are widely separated, the fringes are closer together. If we again reduce the distance between the dippers to less than 1 wavelength, the wave pattern is difficult to distinguish from that produced by a single source. When the two sources are vibrating in phase, they produce crests and troughs in step with one another. Note the position of this interference fringe. When one source is put out of step, we notice the shift of the interference fringes. The regions of maximum and minimum effect are interchanged. The two sources are vibrating at the same frequency, producing the now familiar interference pattern, with the interference fringes occupying fixed positions. Now the frequency of one source is slightly increased. The interference pattern becomes distorted and wheels steadily round. At any point such as this, regions of maximum and minimum wave motion sweep by, producing the effect of beats. As the frequency of the source is further increased, the beats follow one another more rapidly. Beats are moving interference fringes. The beat frequency is equal to the difference in the frequencies of the two sources. Demonstrations of interference can be carried out with any ripple tank, but the Schlieren technique shows the effect more clearly.